High in the Peruvian Andes, shrouded by mist and mystery, lies the ancient citadel of Machu Picchu. This extraordinary testament to human ingenuity stands as one of the world's most iconic archaeological sites, a breathtaking marvel of engineering and design. Its towering walls and intricate structures seem to defy the very laws of construction, particularly given the era of its creation. For centuries, an enduring question has captivated explorers and scholars alike: how was such a colossal city built without the aid of iron tools? The Inca Empire, flourishing in the 15th century, was a civilization of immense sophistication. They developed intricate road systems, advanced agricultural practices, and complex social structures. Yet, remarkably, they never discovered or utilized iron metallurgy for toolmaking. Their technological prowess lay in a profound understanding of their environment and the properties of natural materials. Instead of iron, the Inca relied on stone, bronze, and hardened wood to shape their world. These seemingly rudimentary materials were wielded with an astonishing level of skill and patience. The construction of Machu Picchu represents the pinnacle of their stonemasonry, a technique honed over generations. This achievement becomes even more profound when considering the challenging mountainous terrain. The primary building material for Machu Picchu was granite, a ubiquitous and highly durable stone found throughout the region. This igneous rock is renowned for its hardness and resistance to weathering, qualities that contribute to the citadel's remarkable preservation. However, its very strength presented a formidable challenge for ancient builders lacking metal implements. The sheer scale of granite extraction and manipulation required immense effort and ingenious methods. Quarrying the granite blocks was the first monumental task in the construction process. The Inca identified natural fault lines and fissures within the bedrock, exploiting these weaknesses to detach large sections of stone. They often employed a technique involving the careful placement of wooden wedges into natural cracks or intentionally carved grooves. These wedges were then soaked with water, causing the wood to expand and exert immense pressure, gradually splitting the rock. Another method likely involved thermal shocking, a process that exploits granite's thermal properties. Large fires were built directly on the rock surface, heating it intensely. Immediately afterward, cold water would be rapidly poured over the superheated stone, causing it to crack and fracture due to sudden temperature change. This allowed for the extraction of manageable, albeit still massive, blocks. Once detached, the rough-hewn blocks needed further shaping and refinement. This stage primarily involved percussion, using harder stones as hammerstones to chip away at the granite. Diorite, a dark, dense igneous rock, and hematite, a naturally occurring iron oxide mineral, were commonly employed for their superior hardness. These tools were wielded with incredible precision, gradually reducing the raw blocks to the desired forms. The shaping process was not merely about brute force, it required a deep understanding of the stone's grain and fracture patterns. Skilled masons would meticulously tap and strike the granite, guiding the breaks along predictable lines. This careful work allowed them to achieve the remarkably smooth surfaces and precise angles seen in Machu Picchu's walls. The sheer volume of stone processed in this manner speaks to an extraordinary workforce and organizational capability. Transportation of these multi-ton blocks from the quarries to the construction site was another logistical marvel. While the main quarries were located relatively close to the citadel, the uneven, steep terrain presented significant hurdles. Without wheeled vehicles, the Inca relied entirely on human power, leverage, and simple mechanical principles. Hundreds, perhaps thousands, of laborers would have been required for each block. Ropes woven from strong plant fibers, such as agave or ichu grass, were essential for pulling and maneuvering the massive stones. Timber rollers, placed beneath the blocks, would have facilitated their movement over relatively flat or gently sloping ground. For uphill sections, earthen ramps were likely constructed, allowing the blocks to be gradually dragged into position. This process demanded immense coordination and physical strength. The most iconic feature of Inca masonry at Machu Picchu is the precise, mortarless fitting of stones, a technique known as ashlar masonry. Each block was individually carved and shaped to interlock perfectly with its neighbors, creating an incredibly stable and durable structure. This level of precision is often described as knife-edge tight, where even a thin blade cannot be inserted between the stones. Achieving such accuracy without metal tools was an arduous, painstaking endeavor. After initial shaping with hammerstones, the blocks underwent a process of abrasion and grinding. Fine sand, combined with water, served as an abrasive agent, rubbed against the stone surfaces using smaller, handheld stones. This slow, meticulous work smoothed the granite and allowed for minute adjustments. The process was iterative, involving constant trial and error. Stones would be repeatedly lifted into place, checked for fit, removed, and then further ground down. This method ensured that each block perfectly matched the contours of its companions. The slightly rounded edges, sometimes referred to as cushion effect, allowed for a small degree of movement during seismic events, a crucial feature in an earthquake-prone region. Beyond the regular, rectangular blocks of ashlar masonry, the Inca also mastered polygonal masonry, where irregularly shaped stones fit together like a complex jigsaw puzzle. This style, often seen in retaining walls and foundations, offered exceptional stability. Each unique stone was cut with multiple facets, providing maximum surface contact and resistance to shifting. The skill required to envision and execute such intricate interlocking patterns is truly astounding. The construction of the walls themselves involved building temporary earthen ramps and scaffolding. As each course of stones was laid, the ramp would be extended and raised, allowing subsequent blocks to be slid or rolled into their elevated positions. This method, while labor-intensive, was effective for raising structures to impressive heights. The meticulous planning required for such a system highlights the advanced engineering capabilities of the Inca. The overall layout of Machu Picchu demonstrates a profound understanding of civil engineering and urban planning. Terraces, drainage systems, and carefully aligned structures all contribute to its resilience and functionality. The precise orientation of certain buildings to astronomical events further underscores the Incas' scientific knowledge and connection to the cosmos. Every element was thoughtfully integrated, creating a harmonious relationship with the natural landscape. The workforce behind these monumental achievements was organized under the Mita system, a form of labor tribute to the Inca state. Communities would contribute skilled artisans and laborers for specific periods, working on public projects like roads, agricultural terraces, and monumental architecture. This collective effort, driven by a strong societal structure, provided the sustained manpower necessary for projects of this scale. Generations of knowledge and skill were passed down through master masons and their apprentices. The ability to identify the best stone, understand its properties, and apply the appropriate techniques was a highly valued craft. This rich tradition of artisanal expertise ensured the continuity and refinement of their construction methods. The collective memory of techniques and solutions was vital to their enduring success. The Incas' deep connection to the natural world, particularly the revered mountains, also fueled their architectural ambitions. They saw themselves as integral parts of Pachamama, Mother Earth, and sought to build in harmony with the landscape, not against it. Stone, being an enduring element of the earth, held profound spiritual significance. Their structures were not merely utilitarian, they were expressions of their cosmology and reverence for the sacred. Their philosophy embraced patience and a long-term vision. The construction of Machu Picchu was not a project to be completed in a single lifetime, but an ongoing endeavor. This dedication, combined with an unwavering collective spirit, allowed them to overcome obstacles that would seem insurmountable to modern builders without our current technology. The very act of shaping the stone was a meditative, almost spiritual, practice. Machu Picchu stands today as an enduring monument to human potential, a silent testament to what can be achieved with ingenuity, perseverance, and profound understanding of natural resources. It reminds us that technological advancement is not solely defined by metallurgy or mechanics, but by the creative application of available means. The Inca did not need iron to build their masterpiece. They possessed something far more powerful, an unyielding spirit and an intimate knowledge of their world. The ruins whisper tales of a civilization that forged an empire not with steel, but with stone, grit, and an extraordinary vision. As the sun rises over its ancient walls, casting long shadows across its meticulously crafted stones, Machu Picchu continues to inspire awe, inviting contemplation on the boundless capabilities of the human mind and the enduring legacy of those who built with such profound purpose. It challenges us to reconsider the true meaning of progress and the enduring power of collective human endeavor.